problem, we want to find the producer's surplus when the supply for a particular item is given by S of x equals 28 plus 0.36x squared, and the equilibrium price of a unit of whatever they're selling is $64. So the producer's surplus is defined as the integral from 0 to x sub b. X sub b is the equilibrium x, that is the number of items being produced at the equilibrium point where supply and demand cross, of P sub b, that's the price at the equilibrium point, which is 64, minus the supply function. So we need to find X sub b, that is the number of items that are being produced at the equilibrium point where supply and demand cross. And that is where the price we know is 64. Supply, the supply function is price. Supply and demand are both functions that tell you price at a particular X. So we can plug in 64 for S of x right there to solve for X sub b. This is really X sub b squared. Okay, so solving 64 minus 28 is 36. You can see these numbers are going to come out pretty nicely because 36 divided by 0.36 is 100. So X sub b is positive or negative 10 when you take the square root of both sides, but a negative number obviously makes no sense in this situation. So we'll go with positive 10. So the producer's surplus is going to be the integral from 0 to 10 of P sub b, that's the price at the equilibrium point, which is 64, minus S of x, which is 28, plus 0.36x squared dx. And from here, it's simply computational. Before I integrate, I'm going to go ahead and distribute out that negative and simplify a little bit. So, let's see, 64 minus 28, we already know, we just did right here, is 36 minus 0.36x squared dx. So anti-differentiating gives 36x minus, we add 1 to that exponent, so 0.36 over 3 x cubed, and we're going to take that from 0 to 10. So 0.36 divided by 3 is 0.12. 0 to 10. So plugging in 10, we have 36 times 10 minus 0.12 times 10 cubed minus what we get when we plug in 0, which is just going to be 0. So you can approximate that out to the nearest penny.